We are looking at a geometric sequences today. First, what was the arithmetic sequence? Okay, so we have a common difference. an minus 1 equals z. For a geometric sequence. They have a common ratio between successive terms. Meaning, if I take one term, divide by the previous term, I get some constant. So, if you look at this one, what is 81 divided by 27? 3. What is 27 divided by 9? What's 9 divided by 3? 3. So in this case, r equals 3, our common ratio. Now, like arithmetic sequences, we have a standard way of writing it that's fairly simple and straightforward. So we have two types of formulas, right? What are they? Recursive and explicit. So the explicit formula, we do first. an equals a1 times r raised to the n minus 1. Recursive. So again, I start with a1 equals a constant, an equals. What do we do from to one term to get to the next? Multiply by the ratio, r. So yes, the recursive formula is very helpful because we can just write it. What do we do to the previous term to get to the next? So this says we are multiplying whatever the term was before it by r to get our next term. So if we were writing this sequence up here in this form, what would a1 be? 3. Okay, so 3. What is r? 3 n minus 1. That would be the equation. If you're down here, a1 equals 3, an equals 3, a n minus 1. Everybody with me? So it's similar to arithmetic, it's just instead of adding the same number each time, we're multiplying by the same number each time. Now, when you're in geometry, do you remember something called a geometric mean? It's the geometric average versus arithmetic average. Arithmetic average. And everybody knows how to get the arithmetic average, right? What do you do?
You add all the terms,
add and then divide, right? Now, geometric mean. If we extend that, so what changed from arithmetic sequence to geometric sequence? We changed from to multiplying. So if we were doing a geometric mean, what do you think you'd do? Okay? Yeah, multiply terms, and then to get your geometric mean, or arithmetic mean, what do we do after we add the term? Okay, so what do you think you're going to do after we do this geometric mean? Okay, so if we go everything we're doing is one step more difficult, or one step down. So we went from or one step more difficult, I mean. From addition, we went to multiplication, since addition is repeated multiplication, right? What would be repeated division? Rooting. So, what do you think you're going to do? Multiply and then root. So if we have 5 numbers, we take the 5th root. So let's say if we're doing the geometric mean between, say, 20 and 60. Actually, let's do some smaller numbers, make it easier. Say 2 and 8. Geometric mean between them? Do 2 times 8 is, and then square root, because you got 2 numbers, 4 would be the geometric mean between 2 and 8. Okay. So instead of adding and dividing, which is arithmetic mean, geometric mean multiply and root. So, anybody done that before? Oftentimes taught in geometry class. No? No, remember that? Okay. So, now we're going to extend that idea of geometric mean. So, geometric means in a sequence. Are terms between, unknown terms between known terms of a geometric sequence. So this would be an example. If I have the number 40, I'm going to say there's 2 numbers here and then a 5. These 2 numbers would be a geometric mean because they're unknown between the other parts. The geometric means is the term of are unknown terms between known terms of a sequence. So how do we get them? Well, what would we do to 40 to get to the next term of a sequence? Well, if it says this is geometric sequence, what do we do to get from one term to get to the next? Multiply by r. So this one we know is 40r. What's the next one? 40 times 2r, r squared. You see it? And then this one would be 40r cubed. Okay, everybody follow where that came from? We multiply by r to get the next term, multiply by r again to the next term, and multiply by r. Now we can write an equation. 40r cubed equals what?
40. Wait, no.
5. Do you follow that? Okay? Because remember, each time we multiply by r to get to the next term. Now, how are we going to solve this? We have r cubed equals 1/8. 5 over 40 simplifies to 1/8. And then cube root. Remember, we multiply and then root for geometric mean. So what is the cube root of 8? Therefore, what would this term right here have to be? Okay, so 20. And what this one have to be? And then this one would be 5. Okay, everybody follow that? So basically what we recognize is that to get from one term to the next, we have to multiply by r in each case. Now if there were 10 terms, we'd have to, between these, we'd have to multiply by r, and end up with r to the 10th. But we still follow the same process. Now it becomes the question of, remember we added up arithmetic sequences yesterday, right? We say sum of 1 to 100 is 5050. What if we do a geometric sequence? Clearly that formula is not going to work because it was dependent on addition. So this is for geometric sums, or a geometric series. Sn equals so A1 times 1 minus r to the n over 1 minus r. This one, it's a bit harder to justify why that works, and I could do it, but it would probably be very complicated, and I'd rather not. We can just say that works. We're going to add another thing up here. How about an infinite geometric series? So this is saying we're doing sum of equals n equals 1 to infinity of a n. And I'm going to write this in the geometric series formula. A1 r to the n minus 1. So now let's look back to that beginning problem we had. Okay, we're just going to look at this problem right here. What is A1? 4. What is common ratio? 1/2. So 1 minus 1/2. What's 1 minus 1/2? What is 4 divided by 1/2? 4 divided by 1/2? 8, which is what we had over here. So this formula, we can add up an infinite series, as long as it is geometric. What if we had an arithmetic sequence that was infinite? We watched a video about that, about one of them. You remember what it was? 1 plus 2 plus 3 plus 4, what do we get? Negative 112. Arithmetic sequences don't add up very nicely. Do all geometric sequences add up nice? So let's test something. So, say, get 4 volunteers to do this one, and then we can do several of these. N equals 1 to infinity of, say, 3, 1, I should do 10 to n minus 1. Who wants to do that one? Okay, so Luke, get 2 more people. Okay, Jensen and Reed. Okay. Then another one we're going to do, sum n equals 1 to infinity of 5 times 1/4 to the n minus 1. Okay, some people can do this one. You can do that one. Okay, Rena, Emily, and Nicholas. So, use the formula, and let's do a couple more. N equals 1 to infinity of, let's just do 8 to the n minus 1. Okay, so people do this one that aren't doing one already. And start choosing people now. Sienna. Okay, Lily and Kenny. Okay, And one more here. N equals 1 to infinity of 12, 1/3, actually let's do 0.1 to n minus 1. Okay, 3 people for this one. 3 more. Trudy, thank you for volunteering. Grace, thank you for volunteering. And Grace. So do this last one. So use your formula. Okay. So the first one, what do you guys get? Negative what? Negative 130? Negative 1/3. Okay. Okay. Second one. (6.6) repeating. Okay. So 21 over 3. Negative 20 over 3. Okay, so 6.6 repeating. Okay. Third one. I think this is positive, not negative. Okay. Okay, this one. Okay, 1 over -7. This one. 2.3. 13.3. Repeating or not? So 13.3 repeating, like that? Yeah, that's what this means. Yeah, 2 of these are wrong, 2 of them are right. So let's analyze this for a second. What's the first term of the sequence? What's the next term? $30 plus 300. So you keep adding these up and we get negative 1/3. However, before you say, well, we did everything right, you did. You did do everything right. Okay, this one, also wrong. However, not because you did something wrong. In order to use this formula, R has to be between 1 and 0. Okay, why would that restriction need to be there? What? So if R is between 1 and 0, what do you think is going to be true about the sequence? Is it going up or going down? So if I started at 10 and my common ratio is 1/2, what's the next term? 5, 2.5, 1.25. Is that converging or diverging? Converging to 0. Is that going to work with any of these? If you have a ratio between 0 and 1, like if I have 0.9, if I multiply by 0.9 each time, is the number going to 0? Now let's test it. Let's just choose, I don't know, 6 times 0.9. And if I keep going, what's going to happen? Yeah, it's going to 0 in the long run. So this is converging to 0, which means we're going to eventually begin adding such a small number, so we're at the number. So, in order to be able to use an infinite geometric sequence, the ratio has to be between 0 and 1. So it's very likely on the test, or on a quiz, possibly tomorrow or something, that I would give you a sequence like this and say, what's it equal to? And you would say, infinity. This one, infinity. So if you're doing infinite sum, where r is greater than 1, it goes to infinity. Everybody follow that? And it makes sense why that would be. Look at these tests and experiments. So homework for today, 10.3, when would it be due?